Good afternoon, and I would like to warmly welcome all of you to the 9th webinar of the series of webinars organized by the NIFS to celebrate its 40th anniversary. Today's talk will be on basic science during crisis, which will be delivered by our guest speaker, Vidyajothi, Professor W. Kotagama. Now, I would like to invite the co-chair of the organizing committee of the 40th Anniversary Commemoration of NIFS, Professor Deepa Subasinghe, to introduce the speaker.
Thank you, Dr. Shalini. Yes, our speaker today is one of the most influential environmentalists and an ornithologist of our time. He received his primary and secondary education at St. Thomas Preparatory School, Bandarwala, St. Thomas College, Urutalawa, and at St. Thomas College, Mount Lavinia. He obtained a BSc Honours degree in zoology from the University of Colombo in 1974 and gained a PhD on feeding and behavioral ecology of rose-string parakeet at the University of Aberdeen in 1982. Since 1974, he has lectured at the Department of Zoology, University of Colombo, and at the Zoological Division Faculty of Natural Sciences, Open University of Sri Lanka, teaching senior lecturer grade 1 by 1997. Between 1989 and 1990, he served as the director of the Department of Wildlife Conservation on secondment. In 1997, he was appointed Professor of Environmental Science in the Department of Zoology, University of Colombo, holding it until he gained Professor Emeritus status on retirement. During his career, he had served as a consultant to many government and non-government organizations, as well as being a member of several advisory committees in the Central Environmental Authority, Department of National Museums, the Sri Lanka Foundation, and a scientific advisor to the Ministry of Wildlife Resources Conservation. He has also served as the past president of Field Ornithology Group of Sri Lanka, Vice President of Ecotourism Society of Sri Lanka, and member of the Society for Conservation Biology. He has published many books and scholar articles, mainly on conservation and ornithology. He was awarded the 2003 Distinguished Service Award for Environment, Education and Journalism by the International Society for Conservation Biology, and the endemic toad Dutaprinus Kotagama is named after him. In 2017, he was awarded the title Vidyajothi by the government of Sri Lanka. A day gecko, Nemespis Kotagama, was named in honor of him in 2019. It's my pleasure to invite Vidyajothi Professor Sarath Vimalabandara Kotagama to deliver his presentation on basic science during crisis. Professor Kotagama.
Thank you very much for that introduction. First and foremost, thank you for inviting me for this prestigious talk on your 40th anniversary. As you said, the 9th discussion. And you have given me a big challenge, which is somewhat a task to put together. But I believe I have achieved something at the end of the day. And I hope that I can stimulate the fundamental studies institution to reach out to be doing what is required by our country strongly for the future, which is to do basic sciences or fundamental sciences. So let me jump into my slides straight away by sharing the screen. So I want to all of you, good evening or good afternoon. We are just on the merge of either. So basic science during crisis. Now, we have gone through a number of crises over the last couple of years, and for many years past also. So I'm going to be using some of them with my personal experience only at the end of it. But I thought it is more important to lay the foundation for understanding how basic sciences can be of use or not, has not been used in crisis situations. So a little bit of background on science and so forth, but I would like to dedicate this to my teacher in a way, and the person who opened my eyes to look at science in a completely different way from what I have been taught in the schools and at the university itself. Of course, this was while in the university, Professor Carlo Fonseca, late Carlo Fonseca, who did something which was most unusual as a professor at the time. And there was a lot of brickbat throwing and a lot of rigorous critiques of what he was doing. Sometimes we scientists would feel that this would not be the right way to go ahead of doing some things. But he tried to prove, or at least he tried to establish, I wouldn't say I would use the word prove, in fact it's wrong. He tried to establish the fact that firewalking has a physical explanation. So this was against the traditions that prevailed at that time. And so this opened myself to questioning what really science is all about from all what I learned in school and at the university at that time. So there was this very interesting presentation also. You might not hear the sound, but I just would like you to see the details of it. That's Professor Carlo Fonseca in 1973. So very young, and the bottle on the table, Professor Arthur C. Clarke, who was also witness to the event at that time. And the technical officer who was doing these things by showing that faith is not the only item that matters when you do these things, and that there is a physical explanation. There is a publication which came out on this principle also. And well, in fact, we as students at that time also enjoyed doing this firewalking at Queen's Club, which was opposite our hostel at Brody, down Bullers Road. So even Professor Carlo did either run or walk, whatever you want to call it, that's him, going through quite high temperatures, true enough. Right, so what we were looking at then was a question of what is science. So I think it did open up the eyes of many. We don't have bold scientists of that caliber today, sadly, who are willing to challenge some of the concepts that are around. And I think that is a fundamental need for basic sciences. Science, counting from the days of Thales, who is recognized as the father of science. We go down into short history a little bit, but the real science that we talk today is only about 400 years. Sometimes when Needham published his book on the science of China, he took us back to more than 5,000 years back, that is about 500 BC, and showed that science was around in the East much earlier. But the science that we are very familiar with is, of course, what we would put it in inverted commas, the Western science that we are very familiar. In it is, of course, another dimension, which is the institution that you are in, like the fundamental sciences. One must ask oneself, why did Professor Cyril Ponnamperuma have to name this institution the fundamental science rather than the basic science? Is there a real difference? Well, in the face of it, there is really no difference, but there is some difference in the way you practice it. So fundamental science is the human pursuit of knowledge in its purest form, the process by which we develop new theories and start to explain what we cannot understand. It is the first step in unearthing the mysteries of the universe, and it will be therefore what we would say nature and all other things that are around us. Research on fundamental science has to be directed by scientific consideration and not economic ones. But progress in fundamental science often brings great economic benefits. So these are sometimes difficult in a crisis situation like today, when economies by themselves are dictating what we do in our sciences. So let's see whether we are anywhere close to what it needs. Then what are the basic sciences? The basic sciences are defined as the scientific discipline of mathematics, physics, chemistry, and biology. They are called basic sciences because they provide a fundamental understanding of a natural phenomena and the process by which natural resources are transformed. This is from Uppsala University, which talks a lot about these types of things and provides us with a lot of opportunity. So how do you connect the three? Basic science, fundamental science, applied science. Our understanding of nature and the organization of these answers into theories and model is what provides the driving force behind all technological and medical advances. In other words, basic science is really fundamental science. It is the science at the heart of human knowledge. Applied or translational science or applied science, on the other hand, refers to our ability to take this basic knowledge and apply it to real world problems, such as designing an airplane, developing a vaccine, surgical techniques, or a treatment for a specific disease. Now, I think this matters a lot to the IFS because some of us in the scientific world itself, I put myself in the same boat as a majority also sometimes, see the IFS in an eye that is not probably correct with respect to its establishment. We demand sometimes, and the public may be with us in that sense, demanding that the IFS should deliver real practical solutions to what our problems are in this country. But if you look at it is not so. We must recognize it as good scientists, but how far have we enabled it to be? So to getting it right, you have to first be most obvious that without an understanding of how some things work, it's rather difficult to fix it when it fails. This applies to your cell phone as well as to the human body. That does not mean that we should not try at all. In fact, many of the treatments available today have been developed by trial and error. I think we went through this very well with the COVID situation across the world and in Sri Lanka too. Screening drugs that appear effective and trying them out in human clinical trials. In the case of cell phones, people have thrown them into the oven after getting it wet. We have done it with cameras and many things to get the humidity out of the system and see if it works. If it does work, fine. If it doesn't work, what to do? Wetness destroyed it. Second, history has shown that the building blocks of basic science can provide unexpected answers and tools that find important applications in engineering and medicine, and I would say even in the other spheres that we want in the economics. The basic science and research has its own relationships, which also needs to be recognized and understood if we are to know how basic science can provide, or during crises, how it would be applicable. Basic research is performed without thought of practical ends. It results in general knowledge and understanding of nature and its laws. The general knowledge provides the means of answering a large number of important practical problems, though it may not give a complete specific answer to any one of them. The function of applied research is to provide such complete answers. Doing basic research may not be at all interested in the practical applications of this. Yet, the further progress of industry development would eventually stagnate if basic research were long neglected. This actually was something that I found from a document very, very far away, not recently. It's more than, today it will be about 70 years old, from a NSF document, National Foundation document of US. So you see, we must realize that we have a lot to think about what science is all about and how that will affect our thinking at a crisis. Have we performed what is required? I think would definitely come out in crisis situations. And I will show you examples with what I am aware of. So we need to understand science really well. So I have taken some opportunity to skim the available. and put these slides together for that. Understanding science, how science really works, because if not, talking about basic science and its relevance for a crisis situation will mean nothing. Science is a collection of facts. Now, this brings about a very interesting thought for me. Myself, as I am the only guy who is alive today, along with late Carlo Fonseca and Dr. Jayampati Samarakon, we undertook to help the Sri Lanka Broadcasting Corporation to do a year's program on the origin of man every Friday, continuously. And this was a daunting task, but we were looking at it in what we would say in a basic science approach. And we were looking at it in a very scientific process. How did man come about? How did he progress itself? And we were targeting ourselves that by the end of the year, we would be saying where we are at present. So we came up with a very difficult task because we had to do this in Sinhala. Being trained in English and learned in English, of course, Sinhala was not difficult for me, but yet even you must know Professor Carlo Fonseca, he had no other, he also was very fluent in both languages. Professor Dr. Sampath, Dr. Jayampati Samarakon again was okay, but we were stuck. We were stuck with trying to find how do you find a word for facts in science? Now, if facts are the ones that matter, then we need, when we talk in Sinhala, to properly provide the word for the audience to understand. And we were stuck. And it is Professor Carlo who came up with this very fancy long word. He said, Indriya Gochara Pratyaksha. Now that is too long for a single English word like facts, meaning that we need to sense it with our organs and then be convincing with it, and that then becomes the fact. So here comes Professor Nalin De Silva and helps us out of that mess and says Pratyaksha is good enough. So Pratyaksha is a fact in single, but science is based on facts. That is what we need to recognize. A lot of what we learn in the world of science comes from textbooks, which means that sometimes it is easy to fall into the line of thinking that that is all there is, fact on a page. It is true that science can be learned in textbooks, but at the same time, it's an ongoing dynamic process because these facts can change. Is science complete? Most science courses start out with teaching that were new in the 19th and 20th century. This leads to some to believe that science is finished. We have made all discoveries, so what else is there? This is completely untrue. The purpose of scientific research is inherently to explore new ideas, developing new questions, and rehearsing old hypotheses with new research. Science will never really be complete. Now, again, I use it in my teaching and I say, what matters to a scientist is not the confidence level of 95, which has given the result or the facts as acceptable, but the 5% which differed with all the controls in place. There must be something that is making that 5 different from the 95. For a good scientist, it is that 5% rather than the 95, because that is an achieved, but the 5 is a question. So think about it very seriously. There is a single scientific method that all scientists follow. That is how we have been taught in school. The scientific method that is taught in virtually all science courses is a very, very simplified version of what actually happens in scientific research. In reality, science is unpredictable, complex, and involves a lot of people all working on different things in different orders, often all at once. So there's other techniques and methods that we need to think about very carefully. Experimentation. The process of science is purely analytical and does not involve creativity. Not so. It's possible that this myth stems from the linearity of the scientific method, because we all need to get a hypothesis, the experiment, the the analysis, the conclusion, and so on. Actually, science is not a series of steps, but rather a creative thinking process used to develop new or alternative hypotheses or seeing old data in a new light. Creativity is not limited to artists and musicians. Scientists need to be creative too in order to achieve the final objective. When scientists analyze a problem, they must use either inductive or deductive reasoning. This is another common thing that is often said. The truth is that scientists are always using a variety of reasoning when conducting research. The important thing to realize is that it is not about what type of reasoning, but rather how scientists use reasoning to observe how evidence supports or does not support ideas. Do we get this training? Experiments are a necessary part of the scientific process. Again, this is the foundation that we give in school. Without an experiment, a study is rigorous or scientific. This is another example of how the scientific method has been used to stereotype scientific research. If there is not a linear arrangement of steps, it must not be true science. That is the hypothesis, the experiment, the data, the analysis, the conclusion. Is it always the case? In reality, there are many ways to test any scientific idea, and experimentation is just one of those ways. Sadly, it is yet to be seen to say so, whether it is that or not in our teaching. As with any field, hard sciences are more rigorous and scientific than soft sciences, because this distinction also exists when we talk about sciences. As with any field of study, lines are often drawn in an attempt to classify types of research. In this case, chemistry and physics as hard sciences, again psychology and sociology or ecology as soft. The reason is that hard sciences require more rigorous study methods and therefore is more trustworthy. Or is older, others are younger. However, the rigor of well laid out scientific study depends more on the investigator's approach than with the discipline. If we know what we are doing properly, it will be hard or soft rather than old or new or details with rules and regulations and doesn't have so with the others. Scientific ideas are absolute and unchanging. This misconception harkens back to the textbook idea that because science textbooks often go fairly unchanged year after year, the ideas within those texts must not be changing either. Even established, well-supported ideas are subject to minor changes based on new evidence. I would even say sometimes major changes. Some research textbooks because it is so new, so cutting edge, and these ideas are always changing and evolving as scientists come up with ways to explain these new phenomena. Because scientific ideas are tentative and subject to change, they cannot be trusted. In this fast-paced, connected world we live in, it sometimes seems like scientists are always changing their mind. One day chocolate is bad for you, the next it is touted as a health food, full of antioxidants and lack of trans fat. What to believe? Part of this stems from the media drawing attention to disagreements or conflicting ideas. Another issue at hand is that new science is constantly changing as scientists make new discoveries and test hypotheses. What you need to know is that change in science due to new evidence is a normal part of the scientific process. How many of us do actually accept it, leave aside, believe it? Scientists' observation directly tell them how things work. Knowledge is read of nature, not built of nature. Observations, while critical to science, are not the only thing considered when conducting research. They are actually just one part of a complex process that involves coming up with ideas about how the world works and seeing how their observations can be used to back up those ideas. So the truth is that scientists are actually always building off their observations, trying new ideas, running those ideas by their peers and modifying texts in order to present a clear and accurate picture for what we observe in the natural world. Sometimes we are not permitted to do this because we have a targeted target, and we are expected to always be with it. Science proves ideas. This is the common thing that everybody has in their heads. The concept of proof in the world of science is not actually very scientific. Science is based on the idea that any idea or hypothesis could be put into question tomorrow if there was supporting evidence, no matter how widely accepted it is today. So science can accept or reject ideas based on evidence, but it does not prove or disprove them. Now, how many times, if you recall, have questioned, have you proved it? How can you disprove this without evidence, and so on and so forth? The fact of the matter is that science does not prove or disprove anything. Then what does it do? Science can only disprove ideas. Much like in the previous misconception, science proves ideas. This idea follows the line of thinking that science has something to disprove, falsify, or reject. That science cannot find evidence to support one idea over another. In science, ideas can never be absolutely proved or disapproved. They can only be accepted or rejected based on supporting or refuting evidence. So everything depends on the type of evidence that we have on the table. If we do not have the right evidence on the table, actual evidence on the table, the acceptance or rejections of science is very much the case. If evidence supports a hypothesis, upgrade to a theory. If the theory then garners even more support, it may be upgraded to a law. So these are the three other levels that we look of: the hypothesis, the laws, and theories. So basically, in reality, hypotheses are explanations that are limited in scope, applying to fairly narrow range of phenomena. The term law is sometimes used to refer to an idea about how observable phenomena are related. But the term is also used in other ways within science and in other subjects. Theories are deep explanations that apply to a broad range of phenomena and that may integrate many hypotheses and laws together. So recognizing these are very important for our crisis today in terms of basic sciences. Scientific ideas are judged democratically based on popularity. The media can be partially blamed for this myth when it makes statements like, most scientists agree that human activity is the culprit behind global warming. The public might be led to believe that scientists all congregate to agree or disagree on hot button issues. The reality is that scientific ideas are judged on their supporting or refuting evidences. It's all what is on the table based on what is collected and put together. The collection and putting together is also one of the needs of science. The scientific theory comes to be accepted by the scientific community only after years of study and careful scrutiny. And even a hypothesis that is accepted by most scientists may not be liked by all scientists, but it is one that the scientific community has judged likely to be most accurate based on the evidence. So it's not something that is universal in that sense. The job of a scientist is to find support for his or her hypothesis. It is possible that this myth probably got its start in introductory lab classes, as they often emphasize getting the right answers and rewarding those who have had correct hypotheses all along. In the real world, science gains as much or more from figuring out which hypothesis might be incorrect as it does from those that are supported by evidence. Scientists strive to remain unbiased in their findings. One of the most difficult things for a scientist, as of many cases and many people, after all, we say we are human. Even though we are scientists, we say we are human, and humans are allowed to be biased. Here you are in an arena where you have to leave that bias and come. So scientists are judged on the basis of how many correct hypotheses they propose. Good scientists are the ones who are right most often. In science, it is not always about getting it right. While being right or coming up with hypotheses that end up being proven correct is appreciated, the scientific community also values those scientists who can spot a flaw in a given argument or test. This is how new ideas happen and how research is furthered. So being able to accept the critique is very important in the science. Investigations that don't reach a firm conclusion are useless and unpublishable. That's the thought that we normally have. This myth is another that has its roots in the scientific method. The last step in this process is always some form of a conclusion. So it's very easy to see how scientist studies that don't reach a firm conclusion might be deemed useless and unpublishable. The truth is that most scientific studies don't reach an exact conclusion. Oftentimes, there are limits to the tests performed, and this leads scientists to offer up alternative hypotheses observed. That's just the nature of scientific knowledge. It is constantly in flux and evolving. Sadly, again, in the basic sciences, how many of us feel that way? Scientists are completely objective in their evaluation of scientific ideas and evidence. But I said we are human. Scientists strive to remain as unbiased as possible when they consider different ideas and opposing hypotheses. But they are only human. Each scientist has their own beliefs and goals, and as a result, might favor different hypotheses for various reasons. This is why the scientific community must remain robust. We can keep our peers in check and help balance the bias. A difficult task, as you all probably know by now. Science is pure. Scientists work without considering the applications of their ideas. Sounds very naive. Why are we in it at all then? While some science focuses on just the pure science and no applications, this is not true for vast majority of scientific research. Sometimes, even basic research that is performed without the potential application in mind might later end up being extremely useful to that particular field of study. If we can convince the treasury on this, we might be in a better footing today. Unfortunately, that is the fact of matter. So you have basic sciences for class 6 also. So are we talking basic science of class 6 or basic science of the undergraduate or the basic science scientist? We also have basic sciences that will look after the structuring and the details of an aircraft, which is an artificial structure flying in the air. So basic sciences, this is just a collection of a few things that are all in the internet. I thought, let's see what are the basic sciences that are there. So there's basic science of the eye, orthopedic basic sciences, and so on. A lot of these things are there. Right, that leaves science behind, which I'm sure has made you more confusing than what you think. It's a very interesting insight to realize what science means to us from what we are practicing and what we are made to practice and what we are made to do in our lives day to day. Sometimes I feel that it is that which is making us not pursue what is required. Often we have been requested and asked, make science meaningful, make your research meaningful for the country, make your research required for the country and address the needs of the country. But when it comes to realizing basic sciences, it is far beyond that. It is the freedom to pursue a goal that is not there at the end, but fallouts are what matters properly. So the way you do it and the questions you put together and pursue the end goal has a lot of fallout, which can result in a lot of benefits on the way. If not, it must be targeted. It still can be basic and it must be targeted. So now to the second part of what my challenge was, the crisis. The crisis, again, I just picked it up from Wikipedia, which I thought we need to always define ourselves as to where we are going. If not, we have our own ideas. So I just pick it up from the most popular or the most widely used non-technical document in the internet. the Wikipedia. The crisis or crisis, adjectively critical, is either any event or period that will or might lead to an unstable and dangerous situation affecting an individual, group, or all of society. So we have had over these couple of years, 20, 30 years, many instances of crises which have happened to affect the society, the country. Today we can say that the whole country is in a crisis. But that is not just only Sri Lanka, I would say the whole world is in a crisis for various multiple reasons, different aspects. So crises are negative changes in the human or environmental affairs, especially when they occur abruptly with little or no warning. More loosely, a crisis is a testing time for an emergency. But how are we going to respond? Right. So now I'm going to go into the examples. I'm using this first one, which is an interesting one, which you can see. On one side, of course, there is a single narration of somebody called Padanama. Andama. It is in Sinhala, but I will narrate to it in English. It's about saying that this is not Australia, this is in Sri Lanka. I don't know how that guy thought that peacocks exist in Australia. And what he was saying to say that these birds were dead in somewhere in Sri Lanka. And what do you do for this? Now, the background to this is that about 2 years ago, 2 or 3 years ago, I was requested or I was asked by the media when somebody said there are peacocks that are expanding in this country and they're causing a lot of concerns to the farmers. What do you do? So I said, well, you have to go through the studies, do all the basic research, find out whether it really is a problem. And if you ultimately decide that it is a problem, you need to take the ultimate step also. Even though I didn't say exactly what that ultimate step is, it is an obvious ultimate step. And of course, it went berserk in the media and they used it as saying, Mahacharyatuma Monaru Maranda Kiyana. Now, that is how we find ourselves in hot water with the media. Now, whatever you tell the media also is looking for the trailer. They are looking for something more ratings at the end of the day. And they found a good way. And what was disheartening is that this is the picture that was there. This picture you see here, we use the pointer. This picture you see here was actually from India. This is the original Indian picture. Mystery death of 20 peacocks baffle forest officials in Malapuram. This is the picture, and you can see the similarity. Now, this is sometimes the irony and the problem that we face as scientists when we are basic. Because if you are at the other extreme, you have what you want in your hand when you are talking. And therefore, you are dabbling with it. But when you are in the basic areas, when you are in the beginning of something, you are talking about an n number of possibilities. And for the media, it is that which helps him to get his higher ratings. And today, in the social media, we say the highest hit. And that is disaster on the line. So next, I want to take to you about the available basic information of this very huge issue. Again, why am I using it? Just only yesterday in the morning, in the Sinhala news, almost the second heading was about so many people dying at Haropatana and so many elephants dying at Haropatana and so on and so forth, and nothing is happening. And this goes on and on and on. Having been in the institution from 89 to 92, I thought this is a very interesting because we had it as human-elephant conflict. We have more than 50 to 60 deaths. Now it's almost like 100 people die every year. And more than 300, 400 elephants die a year. These are from the old data. And there's a lot of property damage and there's a lot of crop damage and all of these things. In order to tackle the problem, we ask the question, how many elephants are there and where is it? And we know basic sciences have supported us by scientists like Dr. Prithviraj Fernando and the others who have done some work and shown us. So we have had in 2011 somewhat an agreed value that the total number of elephants in Sri Lanka is somewhere between 5,879 or so. So, and in each region, how much there is. I want you to see that in the southern region, there is 1,086. So this will come up later on. So what is your solution? Is the tackling. Now, how do you solve this? Would applied sciences help it? Or should we fall on the basic sciences? Or should we use the basic science and the applied science to solve it? I would say both matter and both need to be done. So interfering with the lives of elephant is the result of human-elephant conflict. How do you interfere with the elephants? The major presentation is that we have taken over their property, their land, and we have changed it, and therefore it has made a mess, and they are in the lost conditions. But the real thing is something different. If you look at the research, it is something very interesting, which people are not really talking about. The scientists are trying to say it, but the people are not interested, I would say, and sometimes the scientists are not saying, but they print out. What is not said is that land use change has improved the feeding habitats for elephants, thus attracting elephants which are in close, if not in human resident areas. Now, we don't bring this argument out. We only take the argument from the other side, that humans have encroached the elephant area, is all that we take. But we don't say what we have done in that encroached area other than taking it over. In fact, we have made it better for them than where they would normally be. And the evidence exists in the basic sciences of the study. Elephants have evolved to be generalist herbivore consuming a wide cross-section of vegetation of well over 100 species. Vanculenbergen, Sukuma, Somasiri, Vidyajothi. They tend to prefer grasses as the hence are easy to gather and have few secondary compounds. However, in most habitats, grasses are available only seasonally. The next choice of elephants is pioneer species, as they too grow in abundance, can be repeatedly harvested and persist through the dry season. Later on, there is habitat preference and densities. Asian elephants are an edge species, dependent on forest edge or ecotones. Elephants mainly use such restricted, ephemeral, and seasonal habitats corresponding to forest edge in tall, mature forests. In such forests, elephants occur at low densities of about 0.2 elephants per square kilometer. Sukuma, but there are more evidence also which I will show you. The forest is cut and burned and allowed to regenerate, as in slash and burn or shifting cultivation, the entire area becomes edge habitat. Areas under an intermediate disturbance regime support elephant densities of around 3 elephants per square kilometer, a magnitude higher than tall mature forests. This is basic science in print. Elephant densities in different habitats based on Ishwaran and Punchbanda is one of the earliest publications that was done, we would say, way back 82. Dry grasslands, 2 to 4 elephants per square kilometer. Marshy grasslands, 3.6 to 4 individuals. Scrub patches, 3 to 3.2. Forest, tall, in other words, the good forest that we are clamoring to keep is 0.2 to 1.5. If you look at the food habits, it says another important thing through the basic science. Daily, it needs to feed for 17 to 19 hours. For a day, it needs roughly around 150 kilograms. 50% of daily needs are grasses. The tree food from plants with DBH 2 to 32 centimeters. 75 to 90% of the tree plants are less than 10 centimeter DBH. So it tells us where the food comes from, how much of the food is needed approximately, and which part of the habitat it prefers to hang around, and so on and so forth. Now, these are all fundamental basic information about the elephant's life. It exists. So what is a edge species? Very roughly, it's a pictorial presentation. You have a forest, very little animals here. You have a scrubland, you have water, and you have human habitations which enable these things to happen. And therefore, there you are. That is the area that it normally hangs around. If you look at the transitions over the year in this country itself, with where the elephants are and how many elephants are there, and with what preference they have, looking at that literature that was read to you over the basic sciences, you will see that in a good forest, the habitat preference is zero, or sorry, shouldn't say zero, it's very low. But as we meddle around and change the forest, minimize the forest into not becoming a forest, a chain of cultivation, you can see the preference goes up. And come to agriculture or to diverse levels of habitat with scrubs and food, good food like agricultural food and all of that, you will find that it has a very good preference. But we turn away from agriculture and go into settlements with houses and things like that, the preference starts decreasing. As the forest keeps coming down, the settlements come up, agriculture changes, all of these results in a low preference for the elephant also. If so, why are the elephants still around households? Because it is very clear. The households are still in the village areas rather than in Colombo or Kandy or Matha or wherever. Cities are still this multiple habitat that is available. So the suitable habitat still does exist in a large area of this country and not in the good forest areas. So our response to reduce the conflict has been very simple. We have gone ahead and put electric fences on an administrative boundary. So that's why I have forest department on one side and wildlife department on the side and the electric fence in between. And you have the elephants on this side and the elephants on that side. Now, these could be the same members of a family. And this fence would just be a barrier, which obviously is not going to happen. We have spent more than 10 billion rupees of public money and even more now to try and resolve it. Our fences have not basically taken the elephant away from the village, but it has kept him close to the village. Things have changed subtly over the years on having realized these things from 2006 onwards, but we are still far from reality. Fences in the forest maintains difficult and becomes totally ineffective. Elephants are very good at finding ways to get over it, and they break it and go. Now here we have a design that was done purposefully by clearing either side of the fence so that the elephant doesn't just barge in and it can't see the fence until it hits it, and so on and so forth. The biology tried to blend with the design, and yet for all, they keep breaking and going over. They are very intelligent in doing so. So where is the home range of this animal is another issue that people have been talking about. The home ranges of Sri Lankan elephants vary from 50 to 400 square kilometers. Elephants have a strong attachment to their home ranges as it is related to their fitness. The forcible removal of elephants from their home ranges greatly jeopardize their survival. Now, we used to do these translocations and not do it anymore because we know that from the science that it failed miserably. Until we could get this information, we didn't know, and therefore we did it. But now we know, the science told us that this is not correct. It is not going to work. The animals that were translocated were coming back, and therefore it was not achieving its objective. Translocations have been suspended totally. We are all talking about corridors. But for what? Here is the evidence. There is a common perception that elephants are a migratory species. Some studies on the ranging patterns of Asian elephants have suggested that Indian elephants migrate, and others that they do not. So you have conflicting ideas from India. Radio tracking studies in Sri Lanka have conclusively proven. Now, maybe we should think about science, can't prove anything, huh? Conclusively proven that Sri Lankan elephants do not migrate, but instead have circumscribed ranges to which they show high fidelity. So then why are we asking for corridors? It's a good question. Compared to most range states, the greater extent of elephant range outside protected areas in Sri Lanka. Outside protected areas in Sri Lanka may be another contributory factor as disturbed habitats support higher elephant densities. In contrast, we found people were resident in 69.4% of elephant range in Sri Lanka. And therefore, the majority of elephants occupied landscapes that were largely human-dominated, disturbed, and agriculture. Now relate back to the basic science conclusions of their preference, and you will see where else could they be. Habitats with an intermediate disturbance regime support higher densities of Asian elephants than undisturbed forests. Although undisturbed, unfragmented areas are important, degraded and human-dominated landscape may be critical habitats for Asian elephants, and hence the incorporation elephant conservation plan is vitally important for the species survival. Now, this is the background to changing the human-elephant conflict resolution into human-elephant coexistence. But can it achieve its objective? Having been part of that documentation in 2006, when we brought that policy out, we were very convinced that despite this information that I just read out to you, if we really tackle it properly, maybe the people will accept the elephant in their backyard. Now we are in 2022, and I would say, no, the people have not accepted the elephant in the backyard. So I personally believe, looking at the science, that we may have to revisit the elements and the narration of science and re-look at the objectives of such a strategy for the future. I know a lot of people will not agree, but putting the foot in the mouth is something that I always do. So it's not something that I'm afraid to say. How can you then make that distinctive difference? It may sound very naive, but this also says, the literature also says to us, if we are willing to interpret it for the purpose of what is there, is that our protected area network that is in the country, in most elephant potential areas, are not the best habitats for the elephants. So if we can make it the best habitat for the elephants, we could, over time, not immediately, because we have the evidence to say that they are very attached to their area. So we need a way of enticing them to move away from the human areas into their area, which we will now call the elephant protected areas. And we think in that makes basic science trying to give us a direction to resolve the crisis. I believe it can. Why? This also failed. The large animal holdings to rehabilitate animals, which was proposed in 2002, was never taken up for that purpose. Instead of it, it was taken up to isolate, jail the elephants at Horopatan. We know the result. 500 acres were fenced, 32 animals, but 59 at the end of the day was brought there. An audit was done in 2021, last year. And the report was very interesting. The first phase for the Eastern Wildlife Conservation Holding Ground, 997 hectares in Horopatan in Anuradhapura. All of that was done. Delay occurred in the submission of the information by the department. In preparation of this project, many scope was subject to following limitations. Data had not been updated, absence of data relating to the number of animals. But at the end of the day, we got the data, 215 number of elephants released, 10, 16 were 16, 17, 11, 18, 11. First 6 months of 19 were 4, a total of 52 elephants have been put inside that. But what was the conclusion? According to the report of the elephant census conducted in June 2019, out of 52 elephants retained in the holding ground, only 9 elephants remaining, and 12 elephants had died on various reasons. The department lacked information as to whether the remaining 31 elephants had either died or fled the holding grounds. What an interesting conclusion. It recommends that action should be taken to make the Horopatan elephant holding ground successful before the construction of other holding grounds. Where is accountability? Imagine that 35 elephants have disappeared from Sri Lanka. It's a very interesting challenge for all Sri Lankans who care about elephants and the functions of an institution. What then is the elephant number in this country? It's another basic fundamental problem in resolving the crisis. There is a misconception that elephant numbers in Sri Lanka have been increasing over the past few decades. I don't agree on that. I think it has. All past estimates have been based on expert opinion, except in the Vitarna, which are based on direct counts by Department of Wildlife. Therefore, rather than estimates, the current available numbers should be treated as guesstimates, true enough. Such assessments show that elephant ranges have been continuously decreasing. This is what the literature is saying. But a very couple of slides before, I said that good habitats were increasing. The same publications say this, indicating that elephants' number in fact declining in Sri Lanka. Then what is the better habitats that has been created all this time? Subtly conflicting, subtly conflicting. Will we ever be able to resolve that without a number? That is a question. I leave that. Then we also had in recent times another crisis where all the garbage, especially of the garbage from Dambulla and Ampara and all of these places were getting dumped at places. Now this is from Oliville, from Ampara area, particular area. Wild elephants in Oliville have been found with plastic products and non-digestive polythene in their stomachs after eating rubbish at a dumping, poaching on their habitat. The facts are true. Polythene has been found in the fecal of the elephants. But if you look at the elephants here, and if you have seen elephants at the Yala National Park, I'm sure you see a stark difference in their size. They are very, very well fed. So we came with solutions, thinking that this might be the best thing to do. Put an electric fence around, it didn't work. Then we put a trench around. Still it is not working. They are still on the right side. So elephants at the dump, how does garbage consumption impact elephants? A study was done and here is the result. So the people are there. Elephants feeding on garbage had better body conditions than non-garbage consuming elephants, indicating that garbage provided better nutrition than natural food and was not detrimental to their health. So then what was the argument? Polythene in their fecal matter, yes, that can be a concern and so on and so forth. So, but if this is good for their health, what are we talking about? Sort and use of food to draw the elephants away from people. Would not that be an outcome if you think seriously? Money spent wisely to tackle the waste dumping and elephant conservation. In fact, this is closely there at Digamatana today. Why I say the numbers have not decreased is because of the very same calculations and numbers in the literature. I believe that it has increased and it's going to increase more if their habitat changes along with the basic sciences telling us that they prefer this to that. If we have been told 1,000 elephants in 1900, by 2010 or 11, when we did the calculation, it was between 7,000 and 4,500, 5,800 something. Our numbers have on record, maybe it is wrong, that is a different matter, we don't know, but it's in the administrative reports of the Department of Wildlife Conservation, that in 56, we may have had around 750 animals. Mr. Hoffman said it is around 6,000 in 78, and the Smithsonian study brought the steady state rate of between 2,500 and 3,500. So by 2010, we have 7,004. So definitely an increment. The number of conflicts also have gone up. So how many elephants are there in the protected areas? That's a very, very interesting basic science question to answer in the crisis. And we have only one answer. Udawalawe National Park Elephant Population Status Report of 2008 by Shamina R. De Silva, PhD candidate, University of Pennsylvania. What does it say? A total of 305 adult females have been individually identified in Udawalawe National Park, 2005 to 2007. This means that at least 305 adult females have visited the park to date. 175 of these, 57%, were first seen in 2006, which is when the study began. Since then, there have been an average of 6.3 new sightings per month. These new sightings may include animals who were never before in the park, or animals from the east, that is across Mawara, and west across the sides of the park that visit the central area only periodically. It can also include sub-adult females who mature that month. This number does not include juveniles and males. If we add one calf per adult female, on average, the population making use of Udawalawe doubles to 620. 110 males were identified in 6 months. So total 305 adult females, 110 adult males individually identified to date, making up 415 in that. Population exceeding 750 animals is projected to have visited Udawalawe National Park from 2005 to date, that is up to 2007. The only data that is available for the protected network of Sri Lanka. Question, why is it not feasible, practical, possible in all the other protected areas where we have 13 national parks? Just multiply. There are methods of doing it through basic techniques of remote sensing and the habitat qualities, all of these things are there. And you will see that we have a new way. Basic science can solve the crisis if only we are willing to use the basic science. Next, I take the chemical world. Trying to go quickly. This is the most recent information that I managed to get hold of. 100,000 chemicals on the market. 5,000 chemicals extensively characterized for their hazards and exposure. 10,000 chemicals fairly well characterized for a subset of their hazards and exposure. 20,000 chemicals with limited characterizations for their hazards and exposure. 70,000 chemicals with poor characterization for their hazards and exposure. So when we say that we live in an we live in a chemical world, but what we are expressing here is an artificial chemical world. New chemicals that did not exist. We are living longer, but less healthy. Cancer mortality is going down, but cancer incidents keep going up. That is because we are treating them somehow. Why do we think the problem has anything to do with chemicals? Because this is the relationship. Production index, US chemicals are going up, and now you saw 100,000 new chemicals, and all chemicals that are not natural are irritants of some nature or the other. And the basic science again tells us the potential for cancerous or irritant cell growth is high. Look at the emerging infectious diseases, which we just ran through with COVID-19. It is also on the increase. 30 diseases new to medicine since 1976. I will not go to all the details, but I'm giving you the relationships of how it relates to a crisis. All over. Global examples of emerging and re-emerging infectious diseases across the world everywhere. Could it be that we know what is happening better in our environment through the science, therefore we are in this predicament? And therefore, let's close down all the basics and we would not be in the predicament. Some of us, some people do advocate that also. So is that the proper pathway? What factors are contributing to the zoonosis after the COVID-19? This is what we have asked. When the COVID struck, how did the basic science respond to creating the vaccines? Could we have waited 10 years for a vaccine to meet with the potential deaths of COVID infection? Why did we take the risk to vaccinate ourselves? We still had the knowledge of basic science to convince ourselves that we are not doing the wrong thing. So it's basic science which is giving us the strength. Not really the applied science, which means we'd have to wait 10 years for the vaccine to come out, or maybe a little less, but still we had to wait for a long time. There are all the skeptics who are saying because it works in a monkey and a rat, how does it mean that it will work in a man? So the challenges are still there, but the conviction that basic science is enabling us to face crises is also something that we need to recognize. Emerging infectious disease market trends also. So there is a lot of money there also. Then I come to the most interesting one of 2021, which I am sure every one of you all know very well. I hold very different views about this. I'll come to that at the end. The Sri Lanka government decides to ban chemical fertilizer imports and promote organic fertilizer. I know the media came to me and asked, and when I said, I don't care whether it is fertilizer, chemical or an organic, because my views are totally different from what is happening. And when I did say that, they said, are you Serging Vadakna? So I know what the media was after. They were not after resolving the issue, but they were after getting their ratings. So we did get into a very, very bad situation, I would say, and we exposed ourselves very clearly to a number of questions which we should ask ourselves very openly as scientists, and those who are in the basic sciences and applied sciences, if there is to be on either side, for the debacle. Personally, I am happy that the decision was taken. Personally, I am very unhappy that it was not followed through, not by the person who took the decision, because the follow through is the responsibility of those institutions and persons that are there to do it. So there is a concern here. We were arguing about organic and chemical. How many came out to say that this is not a question of organic and chemical fertilizer? Ask yourself, this is a basic question of providing food to a plant. And what is the nature of that food that you're going to provide to the plant? What are the fallouts of this food that you're providing to the plant? There were those who were trying to argue on this and the other. The real experts, the real basic scientists were not even in the picture. And I believe the IFS also has been working on a type of alternative chemical fertilizer for many years. What went wrong? Why didn't it come out? These are good questions to ask during the crisis. And here is a very fancy letter, which I don't know how many of you all ever saw this letter. I don't know how it came to me, but I have the letter. I'm not exposing, you will have to make the conclusions as to who wrote it. Open letter to the farming community in Sri Lanka, Colombo, Monday, 17th May 2021. This is content from therein. Our pioneering spirit never left us, and the hunger for innovation drove us to explore organic fertilizer for a long time. We have been assessing products from international as well as domestic markets. Our research included cooperation with large local dairy and poultry farms, compost exploitation, and even on converting sludge or biochar into organic fertilizer. Given the high subsidy on chemical fertilizer and low productivity on organic fertilizer, not subsidized within brackets, never allowed us to develop and implement a commercial business plan for organic. I repeat that. Given the high subsidy on chemical fertilizer and the low productivity in organic fertilizer, not subsidized, never allowed us to develop and implement a commercial business plan for organic. With the recent announcement by the government to ban chemical fertilizer, we will intensify the research and activities of all our options to serve you with excellence and performance, as we have been doing for the last 124 years. That is good revelation. Try to decipher it. There was the other group, which was well known for promoting non-chemical agriculture, which is the Monla. And they also wrote a long letter to the president at that time. And in it was this very interesting piece. The use of agrochemicals has had disastrous consequences in the past decades. Widespread use of these chemicals has contaminated the soil and the water, which has directly led to the increase in cancer and kidney disease. Not only have these negatively affected public health, but the overuse of agrochemicals has also undermined food sovereignty, unraveled the ecological balance, and had led to the extinction of many animal and plant species. Since almost all agricultural inputs used by Sri Lankan farmers are imported, it has allowed certain companies to build oligopolies. Currently, agriculture amounts to about 7% of GDP, but about 26% of the workforce are involved in agriculture. Often these workers are poor and receive government welfare assistance. Most of them are malnourished and trapped by microcredit companies to be eternally in debt. Movement to land and agriculture reforms believes that is Monla believes that promoting environmentally friendly agriculture practices can be a solution to all these problems. In the first part of the letter, or in this para of the letter, it talks about kidney diseases, cancers, public health, overuse, undermining food sovereignty, ecological balance, extinction of animals and plants. Where is the basic science to support or not support these claims? How can you enable the basic science to facilitate the reality, the truth, or the acceptable or unacceptable, or the dumping of what it is? A good science background will tell us how can we answer these questions. There is no one-to-one answer to any one of these, but there are answers to potential possibilities. Were we ready as scientists to use it for the future? I leave it for basic science. Then there was a very interesting article by Professor Samaravira and Vijayaratna. Again, I picked up this piece only. Sri Lanka is also aiming to achieve 100% organic farming by banning the importation of inorganic fertilizer in 2021. So with the aim of converting Sri Lankan agriculture into 100% organic one, the government took a policy decision to ban the import of chemicals with immediate effect. This decision came as a surprise to many in agriculture and other fields. Many discussions began to surface, pointing out the pros and cons of going organic as a country. Most of the seeds currently used by Sri Lankan farmers are imported hybrid. This is from that article. These seeds have particular agrochemical needs, including chemical fertilizer. We need locally produced seed varieties that respond well to organic fertilizer. However, such a program related to the conservation and distribution of local seeds, which is vital to the success of environmental friendly agricultural practice, have not been initiated. 21. Maybe true, I don't know, but I am quoting to you from what was written by Professor Samaravira. So, where is the basic science to tackle this? Have we learned a lesson from that debacle to respond to the future in a crisis? A crisis requires a response. The politicians also responded. So they appointed a big committee. Through this, again, I am not going to read everything, appointed big committee, 44 persons, to look into this issue and come up with solutions into the future. All of these things said, climate change is causing problems, agriculture is something, power, all of these, plastics, all of these, please come with a solution. It never materialized. So I do not agree with chemical applications, and that's not new. For many years, from the time I became an environmentalist, my argument has been we are killing the soil. So I have been advocating no input agriculture, which in the global domain is called zero input agriculture. How much of us are thinking on this basic side? Yes, it has its own problems, no question. But it is that which helps us to recognize the research that is needed. Crisis response. Developing locally adapted agriculture systems for a post-industrial future is what zero input agriculture globally is about. There is also then the regenerative agricultural philosophies that have come about since last 4-5 years in a bigger way. The eco-civilization philosophies that China pushed out through the CBD, Convention on Biological Diversity discussions, is another one of that same side. So there are a lot of areas of basic science which can respond to a crisis and get us out of it positively. And that is what I think we in the scientific community should look at. And finally, because this came out in a very couple of days ago, is the waste issue that we have been talking again for many, many years. Waste generation per day, 7,500 metric tons. Daily waste connected per day, 3,500 metric tons in the local authorities. Colombo being the highest and all that. Why I put this is because we had a fuel crisis, didn't we? We almost didn't have public transport, and people are talking about we don't have diesel, so there are no buses and we can't go and so on and so on. But look, we are throwing away 62% biodegradable material in our waste. Stockholm, the world's first capital with 100% fossil fuel-free bus service. There are more than 10 cities that are running public transport on biofuel. Many more in Europe all over. On what? On waste. And there it is only 35% biodegradable waste. 35%. And this is ours. Even our cities have organic waste around 65%. And we can't get it converted to biofuel. Pathetic. where is the basic science operating? Why is it not gone to respond to the crisis? So these to me are what matters. So what would be the future be? A scientist is a person who honestly seeks knowledge about nature without bringing in God or any supernatural. In other words, a scientist is simply a researcher. And there is a new dimension to this also, which might be interesting to those who want to pursue, and you may be already aware of it also. Schemat. Science matters. Liu Lam came up with these ideas in 2008. It has been getting old very fast now. To properly bridge the gap and to advance the search for human-dependent knowledge, a new discipline, science matters, is introduced. Science is human pursuit of knowledge about all things in nature, which includes all materials, systems, without bringing in God or any supernatural. So this is the flow from where I just gave you earlier. Big shift from the 20th century hyper-consumption to a 21st century age of collaborative consumption is underway. The convergence of social technologies, a renewed belief in the importance of community, pressing environmental concerns, and cost consciousness are moving us away from the old forms of consumerism towards one of sharing, aggregation, openness, and cooperation. Basic science will assist and help the process to achieve this on behalf of the planet. We are gone. We are at the end of the tail end. Somewhat our future generation will blame us for this, for what we are leaving behind. That I am not part of that, for the fact that I have been advocating the reverse of all what has been happening so far, to a point of saying environmental friendly development for the last 50 years. So I feel happy that I have done my part, but there will be a lot of guilty conscious people. But will they be guilty of what has left behind for their children? So thank you very much. I hope I have opened the eyes of some or closed the eyes of many, and given you a strength to recognize that basic science is the solution in a crisis. Dwelling into it, jumping into that pit is what we must do without being afraid of, because that is where we find the answers for the future. So Vasanavan, everyone, Saran. I have just done it in time, I believe.
Thank you, Professor Kotagama, for a very interesting talk. And also I must thank the audience, including our chairman, who is present in the audience. Both there's a virtual audience as well as physical audience here. So I thank everybody. And I think I can allow a short discussion if someone wants to express their views or ask any questions. I think few minutes can be allowed.
Thank you. Can I come in?
Yes, please.
Yeah. So I'm Jayatis from Runa. So thank you for a very interesting lecture in which we didn't feel that time is passing. So I have a little question on animal behavior, actually elephant behavior, as you are an expert. So just for my curiosity. So what I learned, what I have heard is that actually man is the most destructive animal when we talk about the environmental damage. So, but all the other animals do not destroy the environment. So as an example, if there's any animal need to feed a plant, normally they do not destroy beyond their requirement. So, but what I have observed couple of years back in Singharaja forest, when I enter into the forest through Kotagama, so with forest guards. So a day before, for that region, a couple of elephants have entered, and they have destroyed I mean, quite a high number of kitul trees, young kitul trees. They have, I mean, there were many young kitul trees, not very young, actually mature just before the flowering. Many kitul trees were fallen on the ground. It is very clear, just it is by elephants, and only little has been consumed from the top, nothing else. So actually, it opened my curiosity and raised a question on my mind, whether elephants or animals do such things. It's a quite kind of destruction. I mean, they have fallen. I mean, there were many fallen kitul trees, and very little have been consumed. So, what is your idea on that? Are they destructive, or is it natural or not natural? I mean, interesting to know that.
Right. Thank you, Jayati sir. Good to hear you after many years. First, I must tell you, I am not an elephant expert. I am a knowledgeable person on elephants. I am not an elephant expert. I am a birdman. But I will answer your question because I think I get the gist of it. First and foremost, as you said, it is you who recognize it as a disturbance. So it's a human interpretation of an animal action. Now, why should the elephant push the kitul tree and only consume the top piece? Because that is the place where the natural elephant would have its food. It's only the tender part of the kitul tree that it has the food that it wants. But if you think of it as of the captive elephant, we don't give the tender part. We get the ball part of the main of the thing, split it up, and then give it to the elephant to eat because that is much sweeter. I hope you know that, right?
Yeah.
So that way the elephant gets addicted to that and he forgets the point which he normally would be eating. So that is the reason. So the bit from a big tree is all that it needs. It doesn't need, but elephants are by norm itself somewhat destructor of nature. But then that is what its role in the nature is, not to everything that it breaks, because wherever an elephant has gone, you will see a lot of things being broken down and put on the ground, and things like even branches and leaves and things like that. That is its habit. So it's a functional element in nature where the elephant is to somewhat break. And if there was a study, I think Vankulenberg and people like that did in Yala, where some of the Manilkara trees did not grow beyond a certain height because the elephants kept on breaking them, the Bahumia trees and things like that. There's some article on elephant damage to Yala National Park, right? But all that happens because that is the way it feeds. So we can interpret it as a destruction. I don't say that is not fair because that is how we see it. But in terms of the elephant, it is not a destruction for him.
Okay.
Also, we have to realize that kitul somewhat is a non-random plant. I don't know whether I'm getting the idea because it just doesn't grow anywhere. It grows in clusters in places. because the seeds have to fall and it has to go through that process and all of that. Our traditional story about the seed having to go through the polecat is no longer very much science, but when it grows, you see Kitul Mandi, no, we call it aggregates of places. So when you see a number of trees being pushed down at one location and only the consumable portion has been taken and the rest just lies, in our eyes, it is destructive. But in the actions of the elephant, it is not destruction. That is the role of the elephant in somewhat ways. When you compare the elephant activity in nature, it actually breaks and tears apart a lot of substances and eats only a little of it. It throws away a lot. The elephant trail in the jungle is very easy to recognize because on its way, it would have broken branches, it would have eaten a little bit and dumped away. Even tussocks of grass, it just takes it, eats the luxuriant part and drops the rest. But then that is a process of facilitating the organic turnover in the forest itself. So I don't feel that it is a destruction because it is a facilitation of the dynamics of the forest turnover. And that is why it prefers a lower, a diverse, scrubbier forest type to the high forest because it can't get to the trees or whatever it is and the food doesn't exist there. So your concern is fine, but it's a human concern, not an animal concern. Animals do this.
Thank you very much. Okay, thank you.
Thank you, Brother Kotagama, for very explanative answer. And I can see our chairman, Sumitipal, is also raising hands. So
yes.
Professor Kotagama, thank you very much for that very interesting, thought-provoking, stimulating lecture. Really grateful because this is the whole idea of this series, to stimulate intellectual debates. My question to you is, are you aware of any body of research, literature on the human subject research, people's attitudes, beliefs in relation to this elephant human conflict?
There is some. Not very much, there is some. There are some from India which has come out, but from Sri Lanka itself, there is very little how people react to elephants. If I put it in a more subtle way,
not only react, even the beliefs, assumptions.
Yes, those things do exist. We have Verenigala has done some work on that. His work, there is very little new work that has been done. Verenigala's work in the good old days, and then some of the work done by Tennant and people like that on how people see elephants. Of course, the issue there is, are they scientific? That is one of the problems with human narrative ideologies, thinkings, how do you, the sociology side of it. So there are some social studies, very much more in the recent ones. In India, there are a couple of Indian studies.